Welcome to Vidhai, and this video is brought to you by Exams Vidhai. Everything is possible. So, Exams Vidhai is a non-profit initiative by the students of IIIT DM Kanchipuram to give free coaching and resources to the students preparing for national level competitive examinations like NTSE and NMMS. So, in this video, we are going to discuss a new topic from physics, magnetism. In this magnetism, we'll be having the following subtopics. First, we'll go with introduction, then types of magnets, magnetic properties, magnetic field, types of magnetic materials, Earth's magnetism, and finally we'll sum up the topic. Okay, before jumping into the lesson, let me ask you a few questions. So guys, did you all play with magnets in your childhood? Yes, I hope you all have played with them. Did you all experience some attracting and repelling forces when you brought two magnets near to each other? Yes, you would have faced it. So, what materials attracted your magnet? I think you can make a big list for this. Then, did you all ever try to break a magnet? And now, are the two broken pieces also behaved as magnets? Don't worry, if you could not answer the last two questions, you will by the end of this lesson. Introduction. What are magnets? Magnets are the objects of stone, metal, or other materials which have the property of attracting metals like iron, cobalt, and nickel, and many other magnetic materials. You can see in the picture how the magnet has attracted the tiny metal pins. Next, what is magnetism? Suppose if you bring an iron nail nearer to a magnet, what happens? The iron nail is attracted by the magnet. So this attracting property of magnet is called magnetism. Did you all wonder about how many types of magnets do we have? Yes, we have two types of magnets, natural magnets and artificial magnets. So first we'll learn about natural magnets. What are natural magnets? Magnets which are found in nature are called natural magnets, and they are permanent magnets and they will never lose their magnetic power. Examples: iron sulfide and iron pyrites. Artificial magnets. So what are artificial magnets? Magnets that are made by people in the laboratory or factory are called artificial magnets. Means we humans make these magnets in lab and factories. So these magnets are stronger than natural magnets. And now I will list out how these magnets are prepared in laboratory. These are generally made by magnetizing iron or steel alloys electrically. These magnets are also produced by stroking a magnetic material with magnetite or with other artificial magnets. You will learn in detail in your higher classes. Now you can see an image will pop up. This is a horseshoe magnet and an example of artificial magnets. You can see few more examples: bar magnets, U-shaped magnets, horseshoe magnets, and cylindrical magnets, and many more. Again, these artificial magnets are divided into two types: temporary magnets and permanent magnets. So what are temporary magnets? Temporary magnets are not always magnetic. They are magnetic only when you provide external magnetic field. Means when you stimulate them, they are magnetic. And as soon as you remove the external magnetic field around them, they turn back to their neutral nature. So these are known as temporary magnets. So where they are used in electric bells, cranes, and many other. Is an example of temporary magnets. Now we will learn about permanent magnets. So what are permanent magnets? They are opposite of temporary magnets. Means magnets whose magnetic force never fades away. So these permanent magnets are artificial magnets that retain their magnetic property even in the absence of an external magnetic field. So temporary magnets are only magnetic in nature when you provided external magnetic field. But here, even if you don't provide external magnetic field, these magnets acts as magnets only. So these magnets are produced from the substances like hardened steel and some alloys. The most used permanent magnets of all nickel. an alloy of aluminium, nickel, and cobalt, in short form, ALNICO, ALNICO. So, where are they used? These magnets are used in refrigerator, bar magnets, speaker magnets, fridge magnets, and magnetic compass. Now, neodymium are the strongest and most powerful magnets on the earth. Now, where these neodymium magnets are used, they are used in mobile phones, TVs, laptops, and magnetic separators in the factories. So, till now, we have learned about types of magnets, magnetism. So, now we will be learning how to remove the magnetic properties from a magnet. So, the below are the techniques. So, the first technique is placing the magnet idle for a long time. So, if you place a magnet idle for a long time, it loses its magnetic properties. Similarly, the other techniques are continuous hammering of the magnetic substance, dropping the magnet from a great height, heating a magnet to a high temperature. So, this is an important technique. Heating a magnet to a high temperature. You'll be learning this in your higher classes. Passing a variable current in a coil that encloses the magnet and improper storage of the magnet. So all these leads to the loss of magnetic properties in a magnet. Now, which magnets do you think are more useful in our daily life? Guess what? Nothing. Artificial magnets are more useful because natural magnets are all irregular in shape and they're not magnetically that much strong as these magnets. I mean artificial magnets. And artificial magnets can be given whatever shape we need and they're made very strong too. Now we will learn about the magnetic properties. The first activity that we're going to learn now is attractive property. So what is attractive property? The force exerted by a magnet that pulls magnetic objects towards itself is called attractive property. So to know more about this property, let us refer a below activity. So the activity is you need to take a small iron fillings and then put them on a paper. Now what you need to do is you also put a horseshoe magnet on the paper upon those iron fillings. So what you observe is this image. You could see that iron fillings are all attracted by the magnet, horseshoe magnet. And you can see two places where the iron fillings are attracted more. So they are called as poles. One is termed as North Pole and the other is termed as South Pole. So these poles attract the attraction near the poles is too high. So guys, the second property is repulsive property. What is repulsive property? The force that pulls the magnetic materials away from the magnet is called as repulsive property. So to learn more about this repulsive property, let us see the following activity. The activity is first you need to suspend the bar magnet as shown in the figure. Then you need to hold another bar magnet. The first thing you need to do is subject the north pole of the magnet that you're holding in your hand to the north pole of the bar magnet that is being suspended on this stick. So what you observe is the two magnets starts repelling each other. Now continue this with south pole of your holding magnet with the south pole of the magnet that is being suspended. You will see the similar result. In the both cases, that is North Pole and South Pole, repulsion occurs. If you do this with the North Pole and South Pole, the results will be quite opposite. I mean, attraction takes place. So, repulsive property suggests that when a North Pole of a magnet is subject to North Pole of another magnet, it causes repulsion. And the repulsion also causes in the case of South Poles. So, this is about repulsive property. Now you can pause the video and read this. And now the third property is directive property. So what is directive property? When you suspend a magnet freely, what it does is it places itself in such a way that it points towards the geographical north-south direction of the earth. So this is known as directive property. It means The north pole of the magnet points towards the geographical north direction and the south pole of the magnet points towards the geographical south direction. So this is known as directive property. Below are the images. So till now we have learned about attractive property, repulsive property and directive property. So these are the three magnetic properties that we have. Thank you all. The remaining topics will be discussed in part 2 of this video.